of the industrial internet is our next speaker, Harel Kodesh. Harel is the CTO of GE Digital. He's the GM of Predix. He has been a senior executive at EMC, at Amdocs, at Microsoft, and it's my proud pleasure to have Harel tell us about the industrial internet.
Thanks, Ravi. Let's get the hard work working here. All right, so in case you have noticed, I'm not representing a startup. We will talk about, I think, how we can work with startups to actually build something that is much more interesting than everything, I think, that we've done until today with the enterprise, consumer, and so on. So just to look at the numbers and give you the idea for what is that we're trying to accomplish. The internet is actually booming, right? So you look at Facebook, you look at Google, you look at Twitter and Microsoft and online and so on and so forth. You see billions of users, you see petabytes of information being uploaded. But when you stop and think about that, let's do a number game. If you think about Facebook, for instance, 1.5 billion users, each one of them is uploading about, on the average, a picture every day or two. It's still a considerable amount of information. It's about 35 or 50 petabytes a year of pictures. And then you compare it to what happens in a jet engine. Jet engines, or actually a flight, generates about 200 gigabytes per flight. You have 100,000 flights a day. You have 365 days a year. And if you think about how much data is generated, it's about 1 exabyte. So it's about 20 to 30 times more than Facebook generates information. And nobody's looking at this information. Nobody knows exactly what to do with that. A lot of things are still done in the industrial space the same way they were done 60 years ago. So when people think about how to maintain an engine, it's about how many hours, how many cycles. And the whole industrial ecosystem is organized according to that. They have people, they have equipment, they have a bunch of processes that are all about schedules. When I'm going to basically serve that engine and this engine and that plane and so on and so forth. The issue is that we have to change that because it becomes almost impossible to manage all those things. And that's why when you go and take a flight to Seattle, there is a good chance that you will stay at the gateway because the captain is going to, at the jetway, because the captain is going to come in and say, I'm not going to fly the plane. Somebody should have known about that way before that, but that's not the case. So when we think about what we call the industrial internet, it's a completely different order of magnitude and complexity than the normal internet, be it enterprise and consumers, that we're dealing with. Now I did something bad. Oh. All right. So just again, looking at the numbers, you know, 1 billion plus smart meters that we have to read almost all the time. Ability to actually trade energy in the spot market. That's something that Enron tried to do before they went bust, but now it's coming back with solar energy, renewable energy, and so on and so forth. We're talking about the ability to create a much higher efficiency of energy consumption by checking whether the light bulb needs to be on or off based on the environment around it and based on certain policies. In fact, we started a company about a month ago that is trying to do exactly that, connect solar panels to a bunch of light or smart devices that will allow us to optimize the energy consumption in commercial and industrial space. And then you go on and on. When I talk about 150 million cars, I'm not talking about autonomous vehicles. I'm talking about basic cars that are connected to the internet that allow them to actually tell you that the light is red. So we're talking about very simple things, and even those things have not happened yet. If you look at wind farms generate terabytes of, exabytes of information. Wind farm, if you looked at the big wind turbines, they are actually reacting to the speed and the direction of the wind. But in order to do that, and so what happened is that there's a little controller that senses where the wind is going, and it actually changed the pitch of the turbine to make sure that the turbine is optimized. But when the turbine is optimized, the turbine behind it is sub-optimized because it creates turbulences. which actually changes the optimal level of the wind farm or ability to generate energy. So you need to get all this information, which is petabytes upon petabytes, and you need to understand, is there any pattern that you would like to repeat in order to improve the energy consumption? Now, that sounds like a small sub-optimization, but think about the fact that renewable companies actually are securitizing their ability to generate energy. They come up, they generate what they call yield codes, and this is the stock that you're buying for renewable energy companies. And if the energy consumption is not actually behaving according to a certain curve that they committed to, then this stock is losing, basically a lot of money. And as a result, there's a loss of revenues that far exceeds the actual change in the energy consumption. So we have to improve that. Now, we, contrary to the common belief, we're not trying to compete with startups. We know what we can do. In GE, we can actually do the big things. The big things sometimes have a lot to do with process, a lot to do with deployment of capital, a lot to do with building data centers in all kinds of places. When it comes down to the IQ of the specific smart ideas and how to implement them, this is where we turn to the Hive, we turn to a bunch of other organizations, and I'm happy to say that we actually, so far, it's been going okay. Don't take my word for that. Talk to Ravi during the break, and you'll hear the story from him. When we think about that, we see actually 3 distinct internets that were evolved over the last 20 or 30 years. So again, we, like everybody else, we start with the first web browser, the publicly available web browsers. Windows 95 came up with a Spyglass browser. Netscape came up more or less the same time. And the first beneficiaries of that were the enterprises. And this was going pretty happily and a certain trend until 2005, where with the advance of cell phones, ability to get information readily in the palm of your hand, all of a sudden the consumer internet exploded on the scene. And this has been going on basically since then. The industrial internet, the internet that allows us to optimize industrial outcomes, has not happened at that time. Actually, it's barely happening now. And the funny thing is, if you look at the GDP, this is actually the bigger part of the GDP than enterprise spending and to some extent consumer spending. This is really the most important things, because if we cannot make the industrial internet works, then we're not going to have any power. Then we're not going to have ability to drill gas out of the ground. We'll not be able, or drill oil out of the ground. We'll not be able to have the ability to actually fly planes. We have to make sure that it works, that it's not going to be a single player. It's going to be really a team sport between us and everybody else that is willing to play in that. If you look at what's happening between now and we believe that 2020, 2030, we're talking about $225 billion in revenues for the industrial internet. Between now and 2030, we believe that the overall industrial internet in total will have, or the side outcomes of that will have trillions of dollars in value because the industrial operators cannot operate the way they used to until 5 or 10 years ago. They have to change the way they do that. It is becoming unacceptable or unmanageable to manage that level of that many assets without benefiting from the data that those assets creating. If you think about a turbine, it has more sensors than actually any normal IT systems, and yet for some reason we are not yet at the point where we can take that and process that. So we're approaching the same, this ecosystem the same way that everybody else approaches it. We build a platform, and then we build an application. If you look at the consumer space, you have Alibaba, you have Microsoft, and then you have at the application level, you have applications from Apple, Google, etc. The same thing for the enterprise. For the industrial internet, this plane or this field is way, way younger than anything else. So we at GE intend to play at the level of the operating system. This is why we created Predix. Predix is a cloud-based operating system for the industrial internet. And then we welcome both our own application and everybody else's application that can help the industrial ecosystem. Now the interesting thing about that is that traditionally you could not involve the ingenuity of Silicon Valley or any other place, Seattle, Tel Aviv, etc., in creating value there. We're not gonna, nobody could get download a spec of a jet engine from the internet, and GE, for in turn, would not drop a jet engine on developer's desk. So that ecosystem was very, very rudimentary and inefficient, and as a result, it was only open to a bunch of people that were not really great software developers. We are trying to change that. If there are two smart guys and a dog in a garage in Palo Alto, from starting today or next week or next month, they will be able to play this in this ecosystem. They will be able to put their hands virtually on a simulator of a jet engine. They'll be able to understand exactly how the jet engine works. And if they have a better idea or an idea for a better analytics than what GE can do that, then we will make sure that they can actually connect with the customers, either GE or United Airlines or American Airlines or anybody else that need to consume the results of that level of software, and we'll make sure that it works. In fact, they can do it themselves. They don't need to have us involved. Why is it so difficult? And the reason it's difficult is because our edge devices are not iPads, they're not iPhones, and they're not Surfaces. They are these noisy, dirty, mostly rotating machinery that generate information in a different way than any of the other devices. Most of the information, 40%, not most of it, 40% of the information that is created by those wind turbines and machines is actually spurious. It's not meaningful. Maybe because certain controllers stopped working, since a certain sensor was not accurate. There was all kinds of spurious reading, but what it means that we need to do is that we have to go to the boundary of the cloud and actually clean all the data and prepare it for ingestions. Once the data is inside the cloud, then we can do magic, right? Then we can ingest all this information, we can look at all the information, and we can make sure that the results of that can move back to the edge devices. When you think about the blow-up preventer, which is this thing that didn't work in the Gulf, about 5, 6, 7 years ago, blow-up preventers are actually a fairly complicated piece of software that clamps the oil pipe, in a marine drilling shut when there is an oil spill. And so the right way to go about that is not to try to optimize it, before the rig is built, but really to do it all the time, right? So you don't do it all the time sitting on the rig. You want to do it sitting in your office, with a bunch of workstation, optimizing the software. When you think you're good and ready, then you want to ship it all the way to the drill, about 500 or 1,000 miles away, and you want to make sure that it ships securely in such a way that nobody can futz around with that. But at the same time, you cannot operate it from your desktop because BP will not accept, or Shell Oil will not accept the availability of the cloud at 100%. So when there is a problem, they want the software to be really close to where the problem is rather than rely on the cloud. The same applies for aviation, the same applies for transportation and locomotives, and the same applies for hospitals for a bunch of reasons. So when you think about the industrial ecosystem, it all has to come together, and we're not going to be the only one that is putting it. We're going to build a bridge. We're not going to put the cars on the bridge. What we're trying to do is eliminate the barrier to entry for folks that are working with you, maybe for yourself, or a bunch of other companies. There are certain things that GE can do, and probably not a whole lot of other people can do it, primarily because it is capital intensive. So we need to deploy the data centers in such a way that they will be secure, they will be available for the industrial internet, will be auditable. A lot of our devices, or actually the vast majority of our devices, are considered critical infrastructure by government. So we want to make sure that we can get everything done in such a way that governments will be comfortable with putting this information in the cloud. Because if we don't put it in the cloud, we will not be able to analyze it properly. And then we want to make sure that we do faster innovation. So in order to do that, we're going to have a global deployment. We're building a data center and presence in France, in Saudi Arabia, in the Emirates, in China and Japan. So we have to do it everywhere there is actually our equipment is running, and it's running in 170 countries. So we're not going to be in 170 countries, but we're going to be in quite a few countries, and we're going to have this footprint globally available. And we're depending on the fact that there is going to be interesting workloads that we are not building that will come from other people. You know, they say that GE is, or GE-like companies are not very good working with the ecosystem. And we are very proud at our ability to buck this trend. It is very easy for a big company to be completely unresponsive for smaller companies. First, I can tell you, somebody was on the other side, or trying to sell into big companies. It takes you about a year to find the right person to talk to. And then you realize the right person to talk to doesn't have the money to pay for what you want to sell them. So it takes another year to find the person that actually is all influenced by the person that you talk to and has the ability to issue a PO. And by that time, the company has moved on, and if the unbelievable thing happens and they like what you're building, then all kinds of people start worrying about, well, this company is too small, what we're going to do with them, you know, we cannot rely on them. And indeed, if GE wants to kill a company, all they have to do is just allow a bunch of people to call them. Because once, you know, if you are a 5-people company or 15-people company, you have 300 people calling you because they're really excited, you're dead. So what we did is came up with a process that allow us to work with the companies efficiently. And again, Ravi lived to tell the story. He can tell you his experience. But this is exactly the ecosystem that we're trying to build. Everybody from China Telecom to Foghorn to B Square, you know, so somewhere between 3 and 30,000 people company will cover all of them. And that's the only way, at least in my opinion, to really build the things that we set to build. The issue with GE is that we have, you know, we've been around for 130 years. We intend on being around for another 130 years. So it comes with a certain level of lessons and experiences. And one of the things we try to do as we move into the digital era is to make sure that we can actually develop an ecosystem and a support system and you know, a bunch of companies we can work with and take this whole thing to the next level. Thank you very much.